concave up means increasing slope. So it means I'm increasing f prime. Either it's this or this, so it kind of makes, put those together, it makes a U. You see a U, like opposite of U, that shape like a U, so those go together, which is nice. Second derivative is greater than 0. All of those things are true for concave up. The idea is your slope, it's the slope of the slope. It's like the next level down. So if I said to you, what's the slope here, it would give me a pretty negative number, right? Like maybe -3 or something. But as I start going to the right, now my slope might be -1, which is bigger than negative, right? Now it might be 0, which is bigger than -1. Now it's 1, which is bigger than 0. So as you go, those like surfboard slopes are just getting more and more mild. That's what concave up means. And then concave down is the opposite. So if you got an N, concave forward down is an N. So it kind of makes an N, which is nice. Might have either one of those two shapes. There's a decreasing slope. There's a decreasing f prime. Those are the exact same statement. These are all the exact same statement. F double prime is less than 0. Down, you have those shapes. These are just different ways to say the same thing. So I guess I kind of skipped I jumped ahead to the punchline a little bit. There's some stuff down here I see now. So if f is concave up, then f prime is increasing. And then f double prime greater than 0 means f is concave up. So I wrote those two things up above. This other one. I'm not going. Great. See ya. You can take your place. Concave down, so f prime would be decreasing. And f double prime negative. Second derivative negative means f is concave down. Is there a spot that you could write like a little table? A blank page somewhere nearby? Blank page. Really? So go to the end of 5, 6. Let's do that. So I want to go concave up. Concave. You might want to watch me like make the table. Concave up, concave down. And I want to go. What does that look like on f? If I'm looking at f, f prime or f double prime. Right? There's my table. I guess it's not that much space. That joke occurred to me, but it's not really me. I think we should try. Okay, so you need to be able to, like, I should be able to give you f prime or f double prime graphs or equations, and then ask you where we're concave up and concave down. So concave up, if you're looking at the original graph, is that. Concave down, if you're looking at the original graph, is that. And it might just be part of it, right? It might just be like this part or this part. But that's the general shape for concave up and down out of the original graph. just has to be going up. I can't draw all of them. So like that, or like that, or like that. And so this is going to be decreasing. So it'll be like this, or just down. And then F double prime, if we're looking at the F double prime graph, concave up happens when we're positive or above the axis. That's negative. I was so excited to see the damn camel out. Oh, there.
Oh, there. You can see it now.
I understand.
I understand.
Okay, go back to the book. Okay, so if I were to look at this graph, I'm just going to label a couple things. This is the original graph. So I'm looking to see where this graph's going to go down. I'm looking at the original. So I'm really just looking for like U's and N's. So this part, what would be true about the second derivative? Greater than 0 or less than 0? Greater than 0. This is concave up. We're making a U. Concave up means the second derivative is positive. It also means the first derivative is increasing. And then this part up here is pretty much the opposite, right? Now we're curving down. Maybe back here is right, concave down also. So in this blue part, we're concave up down. Wait, no, I just got all screwed up. That shouldn't be down, right? That should be what? That should be up. Okay, this one's concave down. Why? What's true about the second derivative? It's negative. And what's true about the derivative? It's decreasing. So what we get, there's another thing here. Right there. What's called a point of inflection. That is a concavity switch. How many more points of inflection do we see on that graph right now? How many more? Still there for an answer. 2 more. That is one. And that is one. So if I look at, that's concave up, right? That's concave up, agree? That's concave down. That's concave down. So how many times does it switch like from blue to pink or pink? 3, right? Well, I guess there's maybe you guys are cutting like the edge ones. Yeah. Like, were you cutting that one?
Yes. It's on the graph.
Yeah, okay. Fair enough. So we're like, we understand it. We're good. Okay. All right, let's look at a algebraic one. So we're going to do the same process that we did with the increasing decreasing. We just do it down one more level. So I'm going to take the second derivative. I'm going to find critical point. That's in the top bottom. I get my x line, so I'll put about a number line, make no windows. Do it like the same process. But now when I plug back in, I'm going to plug back into the second derivative. That's what tells me concave. So original tells you y values. First derivative tells you increasing, decreasing. Second derivative tells you concave. So we're going to take the second derivative here. And on those take-home test problems, you're going to have to do all of them, like in the same problem. But I'm just doing concavity here, so I'm going to skip to the second derivative. Not skip straight there. I got to figure it out. So that'd be x to the third minus 12x plus 1 for my first derivative. second derivative. Now what am I supposed to do with that? That is equal to 0, and if there were a bottom, I would set that equal to 0 also. I would factor this. We'll end up looking like it's like 3 times x squared minus 4, and then you can break that down into x equals 2x minus 2. So we solve this, we get x equals 2, and we get x equals negative 2. With me? Same thing we did with the first number. So we're going to make it, and some of you probably aren't making the number line, but just to like put it up there. That gives me my intervals, negative infinity, negative 2. Negative 2, 2, and 2 infinity. And I'm going to plug back. I want to know about the concavity. What level of the concavity? Second derivative. So what am I going to plug back into to find concavity? Is the second derivative. So take like negative 10 and put it in one of these, whichever one you think is easier. Negative 10 to make that like 300, and then minus 12 doesn't really matter. So this, the second derivative, is positive, which means f of x is concave up. And it also means the derivative is increasing. Keep talking about those, I just don't combine it in this case. Negative 2 to 2, let's say I put 0 in. 0 minus 12, which is negative. So in this part, the second derivative is less than 0. So f of x is concave down. And be really careful about, like, I know you kind of want to shorthand notes sometimes, but some people will write like f double prime of x is greater than 0, and then writing down here those are concave up. It's not quite correct. Like, I don't know what you mean is concave up. F of x, f prime, f double prime. Kind of at the point where I've said this every year. Like, you can't really say the word "it" if you're answering a question. I don't know if "it" means the original derivative. Plug in like 10 again to the second derivative because that's what tells me concavity. I'll be like 300 minus 12. That's a positive number. So the second derivative is positive, which means f of x is concave up. So, do I have concavity switches? It's really similar to like the relative max, relative min thing, like when I switch back and forth. But for in the first derivative level, we're dealing with increasing and decreasing, so we care about the order. Like gain to gain, makes a max, deep to gain makes a min. This doesn't make a difference, positive, negative, negative, positive, they're just points of inflection. So if it switches, you have points of inflection. So there'll be a point of inflection at 2 comma something and negative 2 comma something. What do I plug back into to find something? Original, y value. Do any of you guys want to plug that in? I'm going to trust that you can do that. Stop. Stop. Stop doing that. We've kind of already talked about this. F double prime changes signs. It does have to be defined, so it can't be a vertical asymptote. Then this would be switches. So when you do your critical points, when you make your intervals around it, those are possible points of inflection. They're not guaranteed points of inflection. You might like solve it and it comes out where this interval is concave up, and then this interval is concave up, and it doesn't end up being a point of inflection. There's just possibilities. You have to check them. So the first mistake is assuming that if double prime of x equals 0, it's automatically going to be a point of inflection. That's a mistake. It's not. Sometimes when you plug in two intervals next to make sure you see which graph you are looking at. So the 2 is giving me a derivative graph. And I'm looking for points of inflection. I'm going to count. So when the original graph is concave up, what do we know about the derivative? That's what that table is. Original is concave up, what's the derivative? Increasing. So right here, f of x is concave up. Right here, f of x is concave up. And then the opposite too, right? Right there, f of x is concave down. Right there, f of x is concave down. So I'm gonna write them out with like actual notation too. I'm just trying to like help you see on the graph. So concave up from -1 to 1 to 3. 3's got it. Bracket because it's not there. Concave down. Got -4 to -1. I'm not putting a bracket around the -4 because that's kind of like a circle. And then 1 to 2. POI, points of inflection. It's not forced to it's a TV show. So points of inflection happen where we switch concavity. So what are the x values? How many x values? How many points of inflection are there? There's 3, and max, what are we looking at? How'd you get that? Yeah, so it's like the peaks and valleys, right? So right there, because we're going from decreasing to increasing right there to right there. So x equals -1, because that's a turnaround point. 2, because that's a turnaround point. Oh, sorry, 1 and 2. -1, 1, and 2. Is that okay for 3 or for 2? So 3, switch it up by. Now they're giving you the second term. So make sure you realize what you're given there. And it might be tracked. So you can tell me where f of x is concave up, concave down, and that's one. Or were you looking at the second term? It should be 3 points of inflection. Two are positive. Think about, we know that if the second derivative is positive, that means f of x is concave up. We're looking at the second derivative graph, so where it's positive is just above the axis. So f of x is going to be concave up whenever the second derivative is positive or whenever the second derivative is above the axis. So negative infinity to -3 and 1 to 3. F of x is going to be concave down whenever the second derivative is negative. function end up being basically what? X-intercepts? Say that. But be careful with x-intercepts. That's not really the right word. Because if it did this, that's concave up to concave up. So I guess I should say more like it blasts through the x-axis. So x equals -3, x equals 1, x equals 3. If I had to justify it, I would say f double prime of x changes signs, or switches signs. It goes from positive to negative, positive. Could you justify this by saying f of x changes from concave up to concave down? Do I have any evidence of that? What I'm trying to say is don't use justifications unless you're looking at that graph. Like I can only justify these statements with an f double prime graph statement. I can't justify this statement with like an f of x graph statement because I can't see it. Question 2 or 3. Those are hard for people. Like when you get into it, it's probably a little different when I'm up here. But just like going back and forth between these in your brain, like what's wrong with this, what's wrong with this, the next problem is like that's nice. It gets confusing. We will practice. Alright, number 4. This is kind of a couple throwback things. Got a tangent line I gotta worry about. And then we're getting into above or below the graph. Remember, we talked about this before we knew what concavity was, but if I'm concave up, I'm going to draw like a tangent line, is that going to be above or below the curve? Below the curve like the whole time, right? And if it's concave down, when I draw my line, I'll be above the curve. So that's what they're asking for here, is above or below the graph. So, let's find the concavity, the second derivative again. So I want to know, I want to know the concavity of what? So above and below x. So f of x, that guy, I'm not running down. What rule do I have to use? Product, and then there's like a chain rule, which is negative x something. So product rule is the second thing times the derivative of the first thing plus the first thing times the derivative of the second thing. So remember the derivative of e to the blah is e to the blah, but then you got to multiply by the derivative of the blah. This is negative x. Now I'm going to take maybe I should clean this up. Okay. I can take e to the negative x out in front, and that will leave me with 1 minus x on the inside. Make sure that's what we're doing. See what I did there? Just factor out e to the negative x. And I'm doing that because I don't have to, but this to me seems easier to take the derivative of than this. I mean, that's not even true. But I'm going to do it this way. I need product rule again. Second thing times the derivative of the first thing. E to the negative x times negative 1. 2d1 plus 1d2. So plus the first thing times the derivative of the second thing. The derivative of the second thing is negative 1. 1 minus x is. And now I want to know what happens if I plug in x equals 1. So I'm trying to find out if we're concave up or concave down so that I can find out if the tangent line goes above or below. If I plug in 1, 1 minus 1, that's really nice. So this whole part is just gone. So I end up with so yeah, I just end up with this. So e to the negative 1 times negative 1 second river.